under the curve, so why don't we consider like everything on that interval that's under it? Like we only go to the x-axis. So it's saying like.
Yes. So when we talk about area under the curve, we talk about under the curve to the x-axis. Otherwise, it'd be infinite.
Yeah.
Right. Okay. Was that your question?
Yeah.
Okay.
So
Yes.
under the x-axis, then what would you do?
Ooh, we'll talk about that next week. Okay. So we're going to do the same kind of thing, but with trapezoids. So we are still going to have to determine the number of trapezoids, which is what? N. We're going to have to determine the height of each trapezoid. Now this is your delta x, okay, because we're going to have to remember how to find the area of a trapezoid. Okay. The bases of our trapezoid will be determined by the function value. And then we'll find the area and add them up. I'm going to go grab our copies while you write that. Okay. How do we find the area of a trapezoid? Does anybody remember?
Whoa.
Whoa, what? Whoa, my trapezoid man, or whoa, he knows it?
The trapezoid knows.
Whoa, he knows it. Yeah. Okay. So if we have
Also trapezoid.
base 1, base 2, and the height of the trapezoid, this is how you find the area. If you didn't know that already, write it down. Okay. Now let's think about area under a curve. Okay, here's curve. If I'm making a trapezoid, okay, we're always going to the x-axis, right? So here is what our trapezoids would look like. Okay, do you see how that's approximating the area a little bit better? Okay, but if you look at this trapezoid compared to this trapezoid, they're oriented in a different way. So what's happening is this, since it's a right angle, is our height of the trapezoid, and then these right here are our bases. You see that? So our bases come from our function value, right? And then the height of our trapezoid is that delta x. You see that picture? Okay. Your face wasn't convincing, so I need to. Okay? So let's do the problem on our foldable, like we did on all the other ones here. Okay, so we're still going to do, is it n is 4? And delta x is 2 minus 0 over 4, which is 1/2. Okay. So let's talk about our area. Okay. On the front, if you want to draw these, so find the y coordinates at each place, and then we make trapezoids out of them. Well, yes. What? I know that you see the first one as a triangle, but we're still going to do it as a trapezoid just so you see a pattern. Okay, so our first trapezoid has a height of 1/2, right? So we have 1/2 times the height times, since that trapezoid stretches from 0 to 1/2, its bases are f of 0 and f of 1/2. The green comes from the graph. Can I what?
Can you just point out?
Yes. Base, base. So the blue are the bases. So when we think of a trapezoid, these are sideways. Does that help? Yeah. Okay. And they are not isosceles, right? They're not symmetrical, but it's okay. Trapezoids don't need to be symmetrical. Okay. Our second trapezoid stretches from 1/2 to 1. So the area of that would be 1/2 times the height times the sum of the bases. Okay. That's f of 1. It kind of looks like an 11, but it's f of 1. Okay. Our next trapezoid stretches from 1 to 3/2. So that area would be 1/2 times the height times the sum of the bases. Is this annoying? It is, isn't it? Our last trapezoid, 1/2 times the height times the sum of the bases. F of 3/2 plus f of 2. Do you think that maybe there's a more efficient way to write this all out?
Yeah.
I want you to understand where the formula comes from. Does every single one of those area formulas have a 1/2? Let's factor it out. Technically, does it have 2 1/2? The second one represents what? That delta x, right? Then, what else do you notice? Instead of having to write 4 trapezoid formulas, we can factor out the 1/2 times 1/2. But then, these bases, any base in the middle, how many times does it get thrown in the formula? Twice. So f of 0 only needs to be counted once, but f of 1/2 needs to be counted twice. F of 1 needs to be counted twice. F of 3/2 needs to be counted twice. And then f of 2 only gets thrown in there once. So basically our end bases, our outside bases, only happen once. All of our other bases get counted twice because it's a base for two different trapezoids. This base right here that I'm pointing at is a base for this trapezoid and for this trapezoid. That's way less to put in your calculator, right? Okay. So, if x squared is our function, then we have 1/4 times 0 plus 2 times 1/4 plus 2 times 1 plus 2 times 9/4 plus 4, which means our area is 11/4. I'll just calculate that for you. Colby was mad. I'm going to answer Nicole's question and come back to you. We do right here. Well, it's f of 2, which equals 4. Like this is 2 right here. This is the x value of 2. So we wrote f of 2, which equals 4, which is what I have right here. Yes, because you don't have a graph. So without the graph, how would you remember 4? Well, because you put 2 into the x. Yes. Colby, did you figure out your question or did it get answered?
Yeah.
You're good? Okay, so let's go ahead and generalize our formula. Okay? Our trapezoid, area by trapezoid. Okay? Our area is always going to be 1/2 times the height, right? Which we decided was what? Well, we'll write it as height, where height is delta x, right? And then since we're summing up bases, or summing up trapezoids that share bases, you would want base 1 plus 2 of the second base plus 2 of the third base, right? All the way up until only 1 of your last base. Okay? Any base in the middle, we have 2 of, but then we only have 1 of each of the bases on the end points. How do we calculate our bases? F of x, whatever that may be. Okay? The bases are our function values. It's the y value. Okay, so this is the example that we're going to do. Please find me delta x. So the trapezoids are going to be more accurate, but it's kind of well. But the rectangles are going to be more helpful when we shrink them down until they're like infinitely small, and that's what we're really going to work with when we get into like meshing everything together. Okay. So delta x, what is it? 1/6. 2 minus 1 is 1, divided by 6 is 1/6. Okay. So our area is going to be 1/2, because it's always 1/2, times the 1/6, that delta x, times, this is where we get the sum of all of our bases. So our first base would occur at the beginning of our interval. So its length would be f of 1, because we want the function value. And our last base would occur where? At 2, because that's our end point. So we have one base at x is 1. We have one base at x is 2. Those are our end points. And then we have to count double of any base in between because it gets shared. Okay? So since delta x is 1/6, then our next base would be at 7/6. Our next base would be at 8/6. Our next base would be at 9/6. 10/6. Woo. Oh, Mrs. Hellman. Time out. I didn't leave myself very much room. I'm going to have to write smaller. So we have 2 bases at 7/6. And 2 bases at 8/6. And 2 bases at 9/6. And 2 bases at 10/6. What?
How does it end at 2? Because if you do 11/6, that's 7.
And then what's 12/6?
2. I know, but that's 7. 7.
Yeah. It's okay. So when we do like left and right, we only have the height of each of our rectangles, right? And never do we include both the right and the left endpoint. It's either we start at the right and we end up short, or we start at the left and end up short. You know what I mean? Well, since each trapezoid has 2 bases, we are going to have an extra number thrown in. Okay? Because we want the right and the left height for our bases. Okay? So anytime you do trapezoids, yes, you will have one more number in here than there are trapezoids. Okay?
Always have those if there's 5 sub-intervals, you don't have
If, yes, whatever your interval goes from, you're going to have the endpoints if it's trapezoid, both of them. Yes. Okay? So then at this point, we need all of these. Okay. Hey, let's divide and conquer. Pod 1, f of 1. Pod 2, f of 7/6. Pod 3, f of 8/6. Pod 4, f of 9/6. Pod 5, f of 10/6. Pod 6, f of 11/6. Pod 7 and 8, f of 2. F of 1. Fraction. Pod 3. Oh, you did? Yeah. Okay, so 25/9. Pod 4.
I know.
Wait, are we supposed to multiply by 2 right now?
No.
I got 3.25.
I have this now.
So 13/4. F of 10/6. Cloud 6.
157.
And then our last one? 5. Okay? So what happens is we get 721/216, which is approximately 3.338. Keep them as fractions so you can add them all together and then you can approximate. What is your question? And you leave me? Is that what you're So what happens is your calculator approximates, and every once in a while it approximates to where it can't get to that fraction. I know.
And then second hour staff.
That's tough.
Same with third hour.
Okay, we have one more thing to talk about. Ah! Where'd they go? Ugh.
They were right.
Better. He got to go to school today, so whew. I did not want to miss today, so I was thankful for that. Write this down. Write this chart down. Okay, thank you.
What? What is this one?
It's part of it. Do we have this written down? Who said no? Who's still working? Okay, so you have seen us use an equation to get these approximations. In 31, we worked with a graph and a graph only to get our approximations. What happens if we just have numbers? Okay? So I've given you an interval from 0 to 3, and I want us to use 3 rectangles to approximate the area. Well, we're going to do both. We're going to start out with rectangles using left endpoints. Okay? We're going from 0 to 3 with 3 rectangles. What's delta x? 1. We're going
3.
from... So this would be my suggestion to you. I would make a visual representation of where your rectangles stretch from. So if delta x is 1, right? You have a rectangle from 0 to 1. You have a rectangle from 1 to 2. And you have a rectangle from 2 to 3. So our area would be our width, which is 1, times the height of each rectangle. So if we're using left endpoints, what's the height of this first rectangle? 2, because on the very left we have a function value of 2. This second rectangle, its left height would be...
Good morning, Titan sophomores. Today it's your turn to get your 2019-2020 course registration packet for your junior year. Please check in with your Titan Time teacher for the first to get your attendance, and then report immediately to the Titan Theater. Be sure to bring a pencil or a pen.
This
Thank you.
rectangle has a height of 4. Okay? Are we okay with that? Questions? The 4? I have questions about the 4. You okay?
I just don't really know what happened with the announcement.
Okay, were you okay with 2?
Where is it from?
Okay, so this first rectangle stretches from x is 0 to x is 1. If we're doing left endpoints, the left side is at 0, so its height is 2. And from 1 to 5, the left height would be 6. And from 2 to 3, the left height would be 4. Okay, now if we were doing our right approximations, our width is still 1. But now, what's the height of this first rectangle? 6. What's the height of this rectangle? And this rectangle? 5. If we were using the midpoint to get our height, so we still have widths of 1, what is the height of this guy? 4, because that's the middle height. See how this works? What about this guy? 7, that's the middle height. And here, 1, that's the middle height. I don't really want to spell trapezoid. It's a lot. Okay? So the area of a trapezoid, remember we have 1/2 times delta x times the sum of the bases. So our first base is length 2, plus we have 2 bases with length 6, plus 2 bases with length 4, and our last base with length 5.
Whoa, 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 slow down.
You want me to go back to this? So our interval begins at 0 and ends at 3. So those are our bases, right? And then we have double of any base that falls in between. Okay, so then we get our numbers. F of 0 is 2. F of 1 is 6. F of 2 is 4. F of 3 is 5. Who calculated that for me? 13.5?
Yes.
Sorry, I heard like mumble, mumble, mumble. Okay, now, hold on. I gave you a worksheet. That's your homework for the weekend. On Monday, I would appreciate it if you did some of this review so that we can spend the first half of class doing additional problems. I don't want you to wait until Tuesday morning to review for your Tuesday quiz. Like, does that make sense to you? Okay, so if you do the then Monday evening, you could do the review. Make sense?
You post our YouTube then on Monday?
Oh, of course. I'll even post it today.
Yeah.
Okay? Happy weekend!
Cool.
Stay warm. Make good choices.